In this video, we will explore India's historic Chandrayaan-3 mission and its impressive discoveries about the moon. The Chandrayaan-3 mission placed India among the select group of nations that have successfully landed on the moon, and it was the first to reach the lunar South Pole. The Vikram lander and Pragyan rover have already made discoveries that could profoundly impact our understanding of the moon's chemical composition and geological history, providing vital data for future lunar missions. Despite the well-deserved praise, there is something the mission did not discover but should have, and this is intriguing. Did you notice it too? The ISRO, the Indian Space Research Organization, made announcements before the launch highlighting a primary goal: to find water ice on the moon. The South Pole location was specifically chosen to solve this mystery, crucial for establishing permanent bases on the moon. But where is all the water? I am Alex McColgan, and you are watching Astro. Today, we will analyze the Chandrayaan-3 mission, explore its successes, and try to answer this important question. India's Chandrayaan-1 mission helped provide clear evidence that the moon's polar craters might contain water ice. Since the 1960s, there has been speculation about the presence of water on the moon, and in 1971, Apollo 14 found some traces of water vapor on the lunar surface. However, finding water ice has been challenging. Scientists believe that if there was water ice, it would be in the craters of the North and South Poles, areas that never receive direct sunlight and are extremely cold, some of the coldest places in our solar system. In 2009, signs of hydration began to emerge. Chandrayaan-1, carrying a NASA lunar mineralogy mapper, found the first definitive spectroscopic signs of water ice in several craters around the lunar poles. This water mapping was later confirmed by Chandrayaan-2, leaving scientists increasingly confident that there were potentially 600 million metric tons of water ice in the moon's dark craters. Water on the moon is a major breakthrough. With several nations planning to establish lunar bases, obtaining water from the moon's surface would save many resources. Water is vital for human life and can be split into hydrogen and oxygen, useful ingredients for rocket fuel and breathable atmosphere in a lunar base. So, it is no surprise that when Chandrayaan-3 began its journey to the moon, one of the main objectives reported by the media was to find water ice. Chandrayaan-3 was launched on July 14, 2023, comprising a lander module named Vikram, a small rover named Pragyan, and an orbiter module that carried the other two components through space. On August 23, Vikram, with a small Pragyan inside, landed on the lunar surface at the beginning of a lunar day. But time was not on their side. Chandrayaan-3 was a surprisingly economical mission. While NASA's Artemis mission launches cost an average of $4.1 billion each, the entire Chandrayaan-3 mission cost only 6.15 billion rupees, about $75 million, less than many modern science fiction films. However, with this lower budget came technological limitations. When the lunar night arrived, Vikram and Pragyan would be subjected to temperatures of minus 120 degrees Celsius, temperatures they were not designed to survive. A lunar day lasts 14 Earth days. The Chandrayaan-3 mission needed to complete its main objectives within this period, as the chances of surviving until the next day were slim. So, Vikram lowered its ramp, and the Pragyan rover prepared to descend onto the lunar surface. Pragyan is a 27-kilogram six-wheeled rover equipped with an alpha particle X-ray spectrometer, APXS, to analyze the moon's chemical composition by firing radiation and observing the reflected wavelengths, and a laser-induced breakdown spectroscopy, LIBS, instrument, which does something similar by firing a laser at the target and analyzing the light released by the resulting plasma. These two tools together would allow Pragyan to attempt to find water or other interesting substances, confirming their composition for scientists. In the first few days, the results began to come in. Aluminum, calcium, iron, chromium, and titanium were found on the lunar surface, along with other interesting elements like oxygen. Indian scientists were excited about the first in situ measurement of sulfur at the lunar pole. Sulfur is an exciting element to find because it helps understand the moon's evolution over time and indicates volcanic activity in the region. However, despite all these discoveries, one element was absent in the analysis: the important hydrogen did not appear. Pragyan set out to explore further. Guiding the rover was done manually by scientists on Earth, looking through Pragyan's onboard navigation camera. This needed to be done carefully, as the signal delay between Earth and the Moon meant that orders to stop took about 3 seconds, time that could make the difference between avoiding or falling into a large crater. And indeed, this almost happened. Early in Pragyan's journey, the rover had to stop quickly to avoid falling into a large 4-meter crater that the scientists had not initially noticed. I say quickly, but Pragyan's movement speed was 1 centimeter per second, hardly a sprinter. Over its 2-week lifespan, Pragyan traveled a maximum of 100 meters from Vikram. Fortunately, the crater was detected in time, and the scientists could choose another route. However, when observing Pragyan's route, we noticed a second moment when the rover avoided another crater, opting to go around it. Without photos of this second crater, we concluded there was no visible ice there. Vikram did not remain idle during this time. It performed temperature readings of the lunar surface, digging 10 centimeters deep to measure lunar heat at different depths. It measured the plasma content of the atmosphere. Good news, there is not much, so radio communication with the Moon will likely not face much interference. It detected a possible moonquake, which, given the short period of 2 weeks, was great timing. At the end of its journey, in a final moment of excitement, the Vikram lander even performed a hop 40 centimeters high, firing its thrusters to lift off the ground, moving 30 to 40 centimeters from its previous position. Indian scientists wanted to test how easily future landers could propel themselves back into lunar orbit, and this was a useful rehearsal. But none of this helped the Chandrayaan 3 mission find water ice. On September 4th, time ran out. Vikram and Pragyan were ordered to shut down. ISRO scientists hoped to wake them up again after the night ended, but that hope proved futile. The 2 lunar explorers communicated with Earth for the last time. ISRO and the scientific community praised their efforts and called the mission a success. And indeed, it was, as India obtained first-hand data from the Moon that would be extremely useful in building a picture of conditions at its poles, as well as expanding our understanding of lunar history. However, this definitely raises a mystery. When I first heard that water ice had been detected on the Moon, I imagined frozen lakes or perhaps a light frost, like vapor from the lunar atmosphere trapped in dark craters, freezing on the surface and accumulating over time. We know from orbiters like Chandrayaan-1 that there is water ice in these craters. And yet, Chandrayaan 3 joins other missions in not seeing this ice up close. I remember feeling equally disappointed when I saw the images captured by ShadowCam, a NASA camera carried on the South Korean lunar orbiter Danuri. ShadowCam was so good at detecting light that it could see into the polar craters that had not seen sunlight for millions of years without any problems. And yet, once again, there was nothing there. Nothing but barren dust. Given that Pragyan's analysis of lunar regolith did not reveal signs of water molecules, where is the water ice that Chandrayaan-1 detected? Although this mystery is puzzling, Chandrayaan 3 offers us a possible answer. Not through Pragyan's explorations, but through Vikram, which possibly gave a hint of the solution. When Vikram used its chase temperature sensor, it managed to take 10 different temperature readings of the Moon, starting at the surface and advancing in increments of 1 centimeter. What it found on the lunar surface was a temperature just below 60 degrees Celsius, definitely too hot for you to walk around if you somehow didn't mind the lack of air. But interestingly, as Chase measured deeper, this scorching temperature dropped rapidly. At 8 centimeters deep, the new temperature detected by Vikram was minus 10 degrees Celsius. That is a significant drop. From this, we see that lunar regolith is a poor conductor of heat. But this also clearly indicates that the best place to find ice is not on the lunar surface, but beneath it. There is much we do not understand about the Moon and its water cycles. There is growing evidence that the Moon contains plenty of water, and yet, extracting it will require understanding where this water can be found and how it moves during the long lunar days and nights. Is it affected by solar radiation? Is it trapped in hidden deposits? Although Chandrayaan-3 lasted only 2 weeks, which I am sure is less time than ISRO scientists would have liked, it offered us vital insights into the conditions on the moon. Regarding water, at least, it gave future astronauts this advice: if you want to find water on the moon, it might be a good idea to bring a shovel.